Hi everyone. Am I audible? Okay, okay. Hi. Mm, Can you share sheet from you got to server? Okay, uh, that I can do, but it will take some time actually. So yes, I'll try to do that. Okay, I'll try to do that. Hi Surya. Yes, so let's start. Today we are going to revise DP. Okay, so we have recently did the DP lectures, right? So let's revise it once again, and also we'll see some recursion part as well, like how to with along with DP only we'll see the recursive solutions as well. That is what DP is based on. So that will also be covered. Okay, so let's start. So, hi everyone, my name is Rahul Singla. I am SD1 at Innovator. I was ex-mentor in SD at Geeks for Geeks. I mentored a lot of students from major IITs and NITs. I cracked companies like Grofers and Swiggy. And the subjects that I am taking here are Core Java, Oops in Java, and DSA in Java. Okay, and you can use my code rsingla10 and you can get a free Relevel sample test paper. Okay, let me tell you about Relevel now. So many a time students miss out on great opportunities due to multiple reasons. They didn't have a better degree, and or a poor network. Okay, your resume doesn't stand out with those 100 applying for the same startup. You have applied for 50-60 companies but haven't been called for even a single interview, right? So these are the problems we all face at one point or the other. Now Unacademy has introduced Relevel, India's first test hiring platform by Unacademy, which is helping job seekers find their dream jobs. Now you can get a job only on the basis of your skills and talent. You need not to depend upon your network or degree, right? So, what are the benefits of participating in Relevel test? So, over 50 plus companies, including top startups and unicorns, are there. 1,000 plus job positions across business development, front end development, and back end development are there. You can attempt this test for free. This is a free test. Finish your test in a single day of your choice and get your Relevel score within a week. Right, this is the best thing. And with Relevel, you are in a unique position to invite interest from the companies instead of hunting for opportunities on your own. Okay. Sorry. And registering on Relevel is very easy. How you can register is just there is a link in the description box. Just click on that and you will get this dashboard open, and then you have to click on get hired. Okay, and then you have to select a test like business development test, front end development test, back end development test, whichever field you are skilled in, you have to select that test. Okay, after that you have to select a slot, like on which date you want to give the test. After you select the slot, now you have to fill the details of an admit card. You have to fill all the details, and then you have to fill my referral code here rsingla10 if you want a free sample test paper. Okay. And you can see here that in the practice session after you register you will see all your sample papers and you can download them and try them. Okay, just go and register for Relevel today. This is a very good product and this is a very will be helpful for you guys, right? And just join us on Telegram as well because you will get all the updates there only. And just go like, share and subscribe because this is very important, right? And DSA revision, and let's start with DP. Okay, and we'll start with very basic like what is DP, memoization, tabulation, Fibonacci series, staircase, minimum steps to one, all the things that we have already done as well, but let's do it again so that we can revise it. Okay, so yeah, can you teach graphs? See, up right now tomorrow is the last day I'm teaching here, so it's not like will not be possible to teach graphs, but next time wherever I will start teaching at whatever platform or wherever, so like you guys can join there, I can teach at that point, right? So yes, so let's start with dynamic programming. dynamic programming. Okay, so what is dynamic programming? Like it looks like very big term. What are the questions here? How we can do those questions? Right, a lot of things are there in minds of students. Like it is a very big thing, right? For like it seems very big, right? But it is not. It is not that big. You just have to understand it. Okay, how actually you can do it and what is actually happening inside it, right? But what is dynamic programming? Let me tell you that first of all. So dynamic programming is something where what happens is you have a very big problem. Okay, you have a very big problem and a complex problem that you cannot solve directly, right? You have to use recursion. Let's say you are using recursion to solve it, but that recursion is taking a lot of time. Let's say 2 to the power n time. Okay, so in these types of problem we see that if there are overlapping subproblems means that are we repeating same work again and again? Are we repeating same work again and again? So if we are repeating the same work again and again, that work, what we do is we stop doing that by using some extra space. Okay, by using some extra space, what we do is we stop doing that like the repetitive work, and we store that whatever value we are getting, we store that, and afterwards whenever it is needed, we will directly use it from some data structure. Okay, this is what we have to do. So dynamic programming, what we do is we start from a very small problem and we keep increasing the size of the problem. We start from very small problem, then we will solve this part of the problem, then we will solve this part of the problem, then we will solve this part of the problem, and so on. Okay, and at last we will be able to solve a bigger problem. Let's say the bigger problems look like this. So we will solve this much first of all, then this much, and at last the whole problem will be solved. Okay, so this is where we use dynamic programming when there is a very big complex problem and we are not able to solve it directly. And even if we are, in that case what is happening is time complexity is very big. So in that case what we do is we use dynamic programming. Dynamic programming simply means like very simple logic, that the repetitive work that we are doing, we are storing it somewhere, so the next time when we do that repetitive work, like we have to do that work, we will not do it, we will directly use it. Okay, so dynamic programming is basically based on two things. Let me give one example as well of dynamic programming. So there is a greedy approach and a dynamic approach. You guys must have heard of it, a greedy approach and DP approach, right? So what is DP approach and what is greedy approach? The greedy approach is actually, let's say let's take an example. I gave it before as well. So this is the example that we have. So let's say 5, 1, 20, 30, 50, 60. Okay, so we start from here. Let's say I want to start from here and I want to reach here. Okay, I want to find out the minimum cost that it will take, right? I want to find out the minimum cost that it will take. So if you are using a greedy approach, greedy approach means that if we have to, like in greedy approach, we take the best solution at that time. Okay, we think that this is the best solution at this point of time and we will directly go to that. What does that mean? So in this case, let's say if I go here at this point from this path, or I go from this path. Okay, so it is 75, it is so 1, this is 5, and it is total 75 and this is total 91, right? Yeah, so at this point of time what will you choose? Like you will say that okay, this path will take 5 rupees and this path will take only 1 rupees. So at this point of time the best solution is to go at this in this way, right? So the answer will be this path. But you can see here, this is 60 plus 30 plus 1, 91, and this is 75. This path actually took less cost from going from here to here than this path, right? So greedy approach fails in these types of problem, that if you want to find the minimum cost to reach a certain point, in these types of problem greedy will fail, right? We will not be able to find the best path with minimum cost. So what happens in DP is, we explore all the paths first. I'll explore this path as well, I'll explore this path as well, and then I will decide okay, which path I have to go. I already know the answer of this path. Because I have already explored it. Okay, I just have to see that if I am adding 5 to it, how much will be the total cost, and I am adding 1 to it, how much will be the total cost, and minimum of that will be my answer. So in DP what happens is we have all the answers, we explore all the paths, and then we decide, okay, which path is the best path, which path is the optimal path. Okay, this is the difference between VD and DP, right? And when we decide, okay, when now we know that, okay, DP is what we want to use. So in that case, what will happen when we want to use DP? Then we start from a very small problem and we keep increasing the size of the problem one by one, so that we can solve a bigger problem. Okay, so this is what DP is, and let me just tell you two things about DP, that in which cases we have to use DP. Okay, so first thing is, in a problem you have to see that if there is optimal substructure. Okay, and first thing is this, and second thing is if there are overlapping subproblems. So if these two things are there in a question, then you can use DP in that question. Okay, if these two things are there in the question, then you have to use DP in that question. And what does these two things mean? That optimal substructure mean that we have a bigger problem, okay, and that bigger problem can actually be solved with the help of, if we divide it into smaller problems. Okay, there is a very big problem, you can solve that bigger problem by dividing it into the smaller problems, right? What does that mean? That we are substructuring it such that we can solve this part optimally, we can solve this part optimally, and finally when we can solve this smaller parts optimally means in a more better way, like we will be able to get the better answer. So if we are able to solve these two smaller problems, then we are able to solve this bigger problem as well. So there should be optimal substructure thing like recursion. Basically, if we are able to use recursion in that question, then only we have to use that. Okay, then only we have to use it. DP, right? So first condition should be this. That there should be optimal substructure. That means you should be able to apply recursion on that problem. Okay, if you are not able to apply recursion, so then there is no use of it. Okay, what is recursion? Recursion is simply we have a bigger problem, right? And if that bigger problem can be solved by dividing it into smaller problems of the same type, then we use recursion, right? So the first condition for DP is that it can be solved with the help of recursion. Okay, now second and most important thing, overlapping subproblems. Okay, first condition is that, second condition is overlapping subproblems. Overlapping subproblem means that there are problems that we are solving again and again. The same problem we are solving again and again, and we should not do that. Okay, let's take an example of Fibonacci series. So in Fibonacci series, let's say I want to find out Fibonacci of 4, right? How I will do it? So I will be needing Fibonacci of 3 and Fibonacci of 2 to calculate it. Okay, sorry, 2. Now I will be needing Fibonacci of 2 and Fibonacci of 1 here. Here as well I will be needing Fibonacci of 0 and Fibonacci of 1 to solve this. So to solve Fibonacci of 3, what we need? We need Fibonacci of 2, Fibonacci of 1. So but you can see here that here you have calculated Fibonacci of 2, right? Here we have calculated a Fibonacci of 2, that is Fibonacci of 0 and Fibonacci of 1. So we have calculated already Fibonacci of 2, but on the right side you can see that we are all again doing the same thing. Okay, we are again calculating Fibonacci of 2 when we already have calculated it once, right? So how does it work? Like if we write the code for Fibonacci, first of all it will go here, then it will go here, then it will go here, and one by one, first of all Fib of 2 will be calculated, then we will go up, and one by one everything will be calculated, right? So there is overlapping subproblem. This is called overlapping subproblems. So these subproblems are overlapping with each other. That means they are common, right? Fib of 2 and Fib of 2 are common, right? So what we do is, in dynamic programming, the main thing is this, that we will not do it again and again. What we will do is, first time we will calculate it. When the first time we will calculate this Fib of 2, we will store it somewhere, and next time when we want to use Fib of 2, we will not calculate, like we will not call these values again. We will directly use it. We will directly use the value of Fib of 2. Okay, so what I am trying to say is, let's say, coming back from here, so let's take an array. 0, 1, 2, 3, 4. Okay, so what we want to do is, we want to calculate Fib of 4. So what we are doing is, whenever we are coming back from, like we have calculated Fib of 0, so we will fill the value of Fib of 0 here, which is 0, right? We will come back from here, we will fill the value of Fib of 1 here, right? Now we know fib of 2 will be calculated with the help of sum of these two. Like this is just a recursive code, normal recursive code. So 0 plus 1 will be 1. So we will have 1 here, right? So now the next time when I will go on the right side, okay, then again we will see that, okay, we want to calculate fib of 2, but you can see here on the second index we have already filled the value of fib of 2. Okay, so I will directly take it from here. I will not actually calculate it again by calling fib of 0 and fib of 1. I will directly return from here and take the value from this array. Okay, so these are overlapping subproblems and we have to solve it by using some extra space. So DP is normally one thing, like it is simple thing that if they are overlapping subproblems, that we are doing the same work again and again. If we are doing the same work again and again, so in that case we will store the work when we will do it first time, and next time we don't want to do the same work again, so we will store it somewhere, and that storage part we will take directly from there. Like whatever the answer I want from fib of 2, I will directly take from this array. We can use any other data structure as well. Normally we use array. Okay, so this is dynamic programming. Like you will use extra space. You have to use extra space, and that extra space will actually decrease your time complexity to a larger extent. So if in Fibonacci you will see, if you use recursion, it is 2 to the power n, big of 2 to the power n time complexity. But if you use DP, it is big of n only. Okay, by using some extra space, you have decreased the time complexity to very big extent. Okay, so we will see the first question. We will see Fibonacci series only, and I will tell you the recursion part as well, how you can solve recursively, and then we will go to the DP part. Okay. So now I hope this much is clear. Anybody has any doubt in this part? Like what is optimal substructure, what is overlapping subproblems, where we can use dynamic programming, and what is dynamic programming? Anybody has any doubt in this? See, I can, but the thing is, like I'm teaching, like tomorrow is the last day I think on this channel, so you can connect me with like anywhere else, so that I can share in that case, right? So yes, anybody has any doubt in this? Okay. So let's move forward. Okay, so what you have to do is, first of all, you have to see in any question that if you can apply recursion on that question or not. Okay, so if you are able to apply recursion in that question, then you will see that if there are overlapping subproblems, then we will use dynamic programming. Dynamic programming simply means we will use some extra space to actually store the repetitive work that we were doing. Okay, that is the only thing that dynamic programming is, and this is very easy thing, right? Don't make it a very big thing. It is very easy. Okay, now let's come to the first question, that is Fibonacci series. Fibonacci series. Okay, so yesterday also, yesterday I took a class on recursion as well, right? So in that we didn't complete the whole part. So let's see first of all the recursive solution of Fibonacci series. And we know, right, in Fibonacci series we can apply recursion because there is optimal substructure, right? So if we have fib of 4, fib of n can be calculated with the help of fib of n minus 1 plus fib of n minus 2, right? We already know this, right? Like Fibonacci series. If anybody has any doubt in Fibonacci series is actually 0, like for 0th digit is 0, first value is 1. Then if we want to calculate the next value, how we will calculate it? We will take the sum of this. 0 plus 1 is equal to 1. So I will have 1 here, right? Then 1 plus 1 is equal to 2. So the next value of Fibonacci series is 2. 2 plus 1, like we are actually taking the sum of previous two values, and that will make the next term. So 1 plus 2 is equal to 3. So 3 will be here. 3 plus 2 will be 5. So 5 will be here. Okay, 5 plus 3 will be 8. 8 will be here. Okay, and so on. So this is called Fibonacci series. So now we came to a recurrence relation, that fib of n, if you want to calculate any fib of n, let's say I want to calculate fib of 5. Okay, so if we want to calculate fib of 5, we need fib of 4 and fib of 3. Fib of 4 and fib of 3. That means we need the previous two values, like fourth value and the third value, right? We need fourth value and the third value, right? So the recurrence relation that we came out with is fib of n is equal to fib of n minus 1 plus fib of n minus 2, n minus 2. Fib of n minus 1 plus fib of n minus 2. So the sum of these two will give us fib of n, right? I know this much is simple, and you guys know about it, right? So now What is this fib? Don't get confused. This is just the name of the function. So if we write a recursive solution of Fibonacci series, how we will write it? So if I want to calculate fib of 4, like fourth value I want to calculate. So what I will do is I will go to fib of, I want third value and second value, right? And for third value I need fib of 2, that means second value of that series, and first value of that series. For second value again we want fib of 1 and fib of 0. Okay, and 0 and 1 value, 0 value and 1 value we already know. Like 0th value of Fibonacci series is 0, first value of Fibonacci series is 1, and after that we will keep on calculating. So this will be our base case. Our base case is the smallest problem that we can solve by ourselves. Our base case will be that. Okay, our base case is the smallest problem that we can solve. So 0th value is 0 and first value is 1. Okay, so now if we want to calculate fib of 4, it will be sum of fib of 3 and fib of 2, right? It is just a function that I am talking about. Okay, so and fib of 2 and we will keep on doing it, right? So now we can use recursion. Obviously we can use recursion. This is a recurrence relation that we have. Okay, and where we can use recursion? When we can divide a bigger problem, like this is a bigger problem that we have, into smaller problems of the same type. So here you can see, if we want to calculate nth value, we want n minus 1th value and n minus 2th value, right? We need both of these values. That means if we want to calculate fib of 4, we want third value and second value, right? We know about the Fibonacci series. Okay, so that is what I am saying. So thinking of this, we came to the recurrence relation that okay, fib of n will be fib of n minus 1 plus fib of n minus 2, right? So now if we want to write the code for this, how we will write it? So it will be, if we want to write recursive code, so it will be fib of int n. Okay, now first thing, 3 things I told you yesterday as well. In a recursive code, we have to, while writing a code, we have to remember 3 things. Okay, what are those 3 things? So let me tell you. First thing was, we have to assume something. First thing is we have to assume something, right? Assume something. Second thing is we need to assume something, and base case. There should be some base case, right? And third thing I told you yesterday was like small calculation that we have to do. Okay, and in Fibonacci series, how we are going to write the code? First of all, we have to assume something. So what we will assume? We will assume that for nth value, we already know the value of fib of n minus 1 and fib of n minus 2. So our first answer, int answer 1 will be, we will call the same function fib with n minus 1. We are assuming that we already know the answer of this. Okay, then int answer 2 will be fib of n minus 2. Okay, we will assume that I already know the answer of fib of n minus 2 as well. Okay, this is the assumption part. This work will be done by recursion. Okay, now what my small calculation is that I just have to add them. And return them. This will be my small calculation. So what I have to return? I have to return sum of both of them, answer 1 plus answer 2. Okay, so always we take like one value, let's say 4. So the first step that we want to do, what we want to do is we want the third value and the second value. So I am saying to recursion that you give me the second value of the Fibonacci series and third value of the Fibonacci series. What my work will be, I will just add them. Whatever values you will give from here, I will just add them. Okay, so the first thing was to assume something. I have assumed that Fibonacci of n minus 1 and Fibonacci of n minus 2, like these two values, the third value of Fibonacci series and second value of Fibonacci series, will be calculated by recursion. Okay, and then we have to return answer 1 plus answer 2. That means sum of whatever they will give the values, I have to add them. Okay, and now what will be the base case? Base case we already know, the 0th value and the first value. So if n equal to 0 or n equal to 1, if n is any of these values, we have to return n. That means we will return, if value is 0, we will return 0. If value is 1, we will return 1. So base case is also done, assumption part is also done, and small calculation is also done. So this is our recursive solution. Because a bigger problem can be solved with the help of two smaller problems, right? In those cases we can use recursion. Okay, now this is the recursive code, and I will write it as well. Okay, let's write the recursive code first, and then we will go to, okay, one more thing I didn't tell you, that there are 3 things. Okay, first thing is recursive solution. Then we have memoization solution. Okay, and then we have iterative dp. Okay, so these are the 3 things we have. So the first solution we have already written. So every time whenever we are doing a dp question, we will first of all write the recursive code like this that we have written. Then we will go to memoization. I will explain what memoization is, and then we will go to iterative dp. Okay, iterative DP means the last part, the actual DP problem that we want to solve. Like we can solve it with the help of iterative DP. We will not use any recursion. In memoization, we will use recursion plus we will take some space, like so that the time complexity decreases. Okay, but in iterative DP, we will not use recursion at all. Okay, we will not use recursion at all. So this thing becomes more easier. Like this becomes more easier in the starting. If you are just starting doing DP, this becomes much easier. This path. Okay, so first of all, let's write the recursive code, and then we will move to memoization. I'll explain what it is, and then we will move to iterative DP. Okay, so I hope this much is clear. Anybody has any doubt in this part till now? Public static void. Guys, let me know if there is any doubt. Int Fibonacci series. Okay, int n. Now what we have to do is, if n equal to 0 or n equal to 1, this is the base case. What we have to do is, we have to return n. Whatever is the value of n, we will return that. Otherwise, what we have to do is, int answer 1 is equal to fib of n minus 1, right? And int answer 2 is equal to fib of n minus 2, right? And then what we have to do is, we have to just return answer 1 plus answer 2. Answer 1 plus answer 2. This is the simple solution that we have for Fibonacci series. This was our base case. This was the assumption part. We are assuming that, okay, if we want to calculate fourth value, we already have third value and second value. And these third value and second value has been calculated by the recursion by calling the same function. Okay, these are the smaller problems that we have to solve. This one, and small calculation that we have to do is, whatever value I will get from here, whatever value I will get from here, I will add them and return them. Okay, so this is how recursion works. So let me tell you, going deep into it, that how actually it is working. Okay, let me tell you that as well. Like for this question only, so that you guys have a little sense like what I am doing here, how I am doing it recursively as well. So let me tell you that as well, and then we will move to DP. Okay, so for Fibonacci series, let's do it for fib of 4. Okay, so for fib of 4, what is happening is, first of all, I'll call for fib of 4. That means for the same function. Okay, we are calling this function. Let me show you the function. This function for fib of 4. Okay, I want to calculate fourth value. So now base case, there is some base case, right? Now the first thing it is doing is, int answer 1. Answer 1 is to call for fib of 3, right? It will call for fib of 3. So before calculating like anything else, it will first of all calculate fib of 3. So it will call for the same function again, that is fib of 3. Okay, so base case will be, again base case is there, like base case is, if n is equal to 1 or 0, n is not 1, n is not 0, so we will move forward. So int answer 1, again we have to calculate fib of 2, right? Fib of 2. And let me just show you with the tree as well, like simultaneously I will show you a tree as well. So let's say for fib of 4 we called for, then it is calling for fib of 3, right? And from fib of 3, now it is calling for fib of 2. Okay, fib of 2. So base case is, if n is equal to 0, no, n is not 1, n is not 0, so n is not 1 or n is equal to 0, so this is not done, right? So I will again go to int answer 1, and it will call for fib of 1, right? So now fib of 3 called for fib of 2, right? And fib of 2 called for fib of 1, right? Fib of 1. So now what will happen is, when it will call for fib of 1, so now we reach the base condition. What is the base condition? That if n equal to 0 or n equal to 1, we have to return n. That means from here, from this value we will return 1. From here we will return 1. Okay, we will not go further because this is the base case. So from here we will return 1 to the previous value. That means answer 1 will be 1. Okay, answer 1 will be 1. So from here we will return 1, right? We have returned 1 from here. Now what we are going to do? We are going to go for answer 2. So answer 2 is fib of n minus 2. We have to call for fib of n minus 2. That means n minus 2 is, n is 2. So 2 minus 2 will be 0. So we will call for fib of 0. So when we will call for fib of 0, so what will happen? So it is calling for fib of 0 now for answer 2, right? So fib of 0 is, again it will reach the base condition. Base condition is, if fib of 0 is, if n is 0 here, so I have to return n. So from here we will return 0. Okay, from here I have got 1, from the right side I have got 0. Okay, right side I have got 0, from left side I have got 1. Now what we have to do is we just have to return sum of answer 1 and answer 2. So that will be, it is 0. So 0 plus 1 is equal to 1. So from here, for fib of 2 will return now 1. Fib of 2 will return 1 now. Okay, so from here what will happen is, at this point for fib of 3, answer 1 of fib of 3, okay, answer 1 of fib of 3 will be 1. Answer 1 of fib of 3 will be 1. Okay, so now what we have to do? We have to call for answer 2. Int answer 2. Okay, fib of n minus 2. Fib of n minus 2 means fib of 1. Okay, 3 minus 1, 2 will be 1. So now it will call for fib of 1. Right? That means on the right side of it, it has called for fib of 2. So for fib of 3, we need two things. Fib of 2 and fib of 1. Right? So it is calling for fib of 1 now. So fib of 1 is also, it will reach the base condition. So in the base condition, we just have to return 1. Right? When n is 1, this is fib of 1. When n is 1, we have to return 1. So from here also, we will get 1 here. Right? So we got answer 1 and answer 2 for fib of 3 as well. Like from here, it will return 1. So 1 plus 1 is 2. So we have to return sum of these two, which will be 1 plus 1 will be 2. So from here, we will return 2. Okay? From here, so now we know the answer 1 of fib of 2. So now we know the answer 1 of fib of 2. Okay? Answer 1 of fib of 2. Okay, so answer 1 of fib of 2 is 2. Now I will call for answer 2. Answer 2 is fib of n minus 2. Fib of n minus 2 means I have to call for fib of 2. Okay, I have to call for fib of 2. So it will go on the right side now. So it will call for fib of 2. Right? So for fib of 2, now you can see that, see, here I have already calculated fib of 2. Right? Here I have already calculated fib of 2. Here I have to again calculate it. Right? On the right side as well, I have to again go to fib of 2 and we have to do the same process. And we know the value will be same. Value will not change. Fib of 2 value will not change. It will remain 1 only. Right? It will remain 1 only. So this is the repetitive work that we are doing. Right now I am not showing. Okay, it will directly return what? 1. Because we know fib of 2 is 1. Okay, so this is what we have to do. Like in DP, this is what we have to do. That we want that this value that we have already calculated, we should not calculate it again. That means we should not call for recursion again for the two values of it, like fib of 0 and fib of 1. We should not do that in DP. Okay, but in recursion part, like if we are talking about recursion only, then we have to do this. It will call for fib of 0 and fib of 1, right? And then it will return 0, it will return 1, and this will return 1 from it. Okay, so now for 4, fib of 4, we got both the values, fib of answer 1 as well as answer 2. Answer 1 as well as answer 2. So answer 2 is 1 now. Okay, and we have to return sum of answer 1 and answer 2, which will be 2 plus 1 is equal to 3. Okay, so it will return 3 from here. So the answer for fib of 4 will be 3. Answer for fib of 4 will be 3. Okay, so this is how recursion is working. Just let me know, guys, if recursion part is clear. Then I will move to the DP part, how we can solve it with the help of memoization and iterative DP. I will move to that now. Here it will return 3 from here and answer will be 3. Tell me if this is clear. I hope this is right. I hope this is clear. Now let's move forward. Okay, so now let's talk about memoization. Okay, let me talk about memoization now. So what is memoization? Okay, so memoization is actually something that what we do is we use a mixture of DP as well as recursion. Okay, so what we simply do is we actually take, so here you can see this tree. Okay, here we have calculated fib of 2, right? And here we have calculated fib of 3. So here we have calculated fib of 2, here we want to also calculate fib of 2. So what we are going to do is, in memoization what we will do is, whenever whenever we have this function call, okay, whenever we are getting some value from some, so okay, let me just make this tree again for fib of 4. Okay, I hope recursion part is clear. Fib of 3, fib of 2, okay, and here fib of 2, fib of 1, right, here fib of 1 and fib of 0, right, and it will call for fib of 0 and fib of 1. So what I am saying is, in memoization, what we will do is, we will take a array. Okay, first of all, I will take an array. The size of the array will be 0, 1, 2, 3, 4. Okay, the size of the array will be 5. Okay, it will be a 5 size array because we want to calculate fib of 4. 4 means the value, there should be an index 4 for that. Okay, so whatever the value we are calculating, we will take an array of size plus 1 size of it. Okay, we will take 5 size of array because in the indexes we need 4 value, like index 4, so that we can store the answer here. Okay, so now what we are going to do is, whenever we are coming back from any call, okay, from fib of 0 we are coming back and it will return 0, and fib 4, then we are coming back from fib of 1 and it is returning 1. So what I will do is, from whichever value it is returning from, let's say fib of 0 it is returning from, so what I will do is, I will put value in the array. I will store that value. Whatever value they are returning, I will store that value. So here fib of 0 is returning 0. So on the 0th index, I will put 0 there. And first index, I will put 1 there. Right. Now, what fib of 2 will do? Fib of 2 will give the sum of 1 and 0. Okay, that will be 1. Okay, so 1 plus 0, that will be 1. So on the fib of 2, on the second index, what I will do is, I will put 1 there. I will put 1 there. Right. Now, on the right side, see, now for the right side, there is fib of 1. So I can either, we already know the fib of 1 value, so it will, or you can see in this array as well. Okay, in this array you can see that on the first index we have 1. So that means we already have the value of fib of 1. Okay, so we don't have to calculate it. Actually, for fib of 1, we don't never have to calculate it because this is the base case only. So, but this is the case. Now for fib of 3, what will happen is, I have to take the sum of these two, 1 plus 1, 2, and it will return 2 from here. Okay, so fib of 3 will be 2, so we have to put 2 here. Okay, we have to put 2 here on the third index because it has returned 2. Now when I go on the right side, what will happen is, there is fib of 2. Okay, so first of all, what I will do is, I will see in my array that on the second index, if there is any value, like initially what I will do is, I will put all the values minus 1. I'll put all the values minus 1 initially when I will make the array. Okay, now I will see that when I want to calculate fib of 2. Now when I need fib of 2, what I will see is, if there is some value, like if there is any value other than minus 1 in this array, if there is any value other than minus 1 in this array on that position, on the second position, yes, there is 1. So what I will do is, I will not do these operations, I will directly return from here and I will return 2. I will return 1 from here by seeing whatever is stored in the array. So what I have done is, I have taken some extra space and I keep storing the values while coming back from the recursion calls. Okay, whenever we are coming back from the recursion call, we are actually storing the answers for each value. Okay, and next time when we are using it again, we don't have to do more recursion calls. I'll directly return the value by seeing the array. If in the array we have some value on that index, I will directly return it. I don't have to call the recursion. Okay, so now what we have to do is, sum of 2 and 1. 2 plus 1 is 3. So from here I will return 3. Okay, from here I will return 3. So on the 4, or here we don't have to store, but we can store as well, but we can directly return the answer as well because this is the last call, so answer will be 3. Okay, so this is memoization. What we do is, we take an array called dp. This is a dp array we have, and in dp array what we keep doing is, whenever we are coming back from a recursion call, okay, we will keep storing the values on that index. So we are coming back from the 0th index, that means we got the 0th index value. So I will put 0 on the 0th index, I'll put 0. Okay, for here as well I'll put 1. Right, this is called memoization. That we are memorizing stuff, and the next time when we are getting the same stuff, I will directly use it. I will not calculate it. Okay, I will not calculate it. So I hope this much is clear. Anybody has any doubt in this? So I hope this is clear. So let's try to write the code now. right? Let's try to write the code now for this. So now we are going to write a code. Public static int fib memoization, okay, and this we are going to pass int n, right? Now what we have to do, now how we are going to write the recursive code. So we will pass one array as well here, int dp array, okay, as we have discussed, we are taking an array as well. Okay, so now what we have is, we have the array of size n plus 1, okay. So let's say I want to calculate Fibonacci of 4, so what we have is 0, 1, 2, 3, 4. I have these values, n values, okay, n plus 1 size array of dp I have taken to store the values, okay. So now what we are going to do, first of all, see, we have to do the same thing, whatever we have done here, we have to do the same thing. How? Let me show you. That's why first we write the recursion code. What only difference will be, whenever we are coming back from some value, or initially they are all -1 as well, -1, okay. Whenever we are coming back from any recursion call, we have to store it as well, okay, so from here what will happen is, we will take answer 1, okay, and if dp of n minus 1, because we are talking about n minus 1, so if dp of n minus 1 is not -1, okay, if dp of n minus 1 is not -1, then we will directly return it. Or if it is -1, let's say, if it is -1, what we will do is, we will call for recursion. We have to call for recursion only when the value in the dp array is -1, right? If the value in the dp array is -1, then only we have to return, we have to actually call for recursion, right? As we have discussed as well. So for fib of 4, when we went on the right side, that means we wanted to calculate fib of 2. Fib of 2 already had some value, right? Fib of 2 already had some value. So we will return from here what value? 2, okay, directly, because fib of 2 was not -1. So what we are going to do is, if it is -1, then only we have to call for recursion. So now what I will do is, I'll call for recursion. So answer 1 in this case will be fib memoization, and we will call for n-1 and dp, okay. And then what we have to do is, we have to actually we have to store that value as well. So what I am doing is, whatever the value I am getting, so let me just show you here, fib of 3, fib of 2, fib of 1, fib of 1 and fib of 0, okay. So whatever the value I am getting, so I am calling recursion only when dp of n-1 is -1. That means dp of n-1 means, so for 2 I'll call for fib of 1, okay, I'll call for fib of 1. So if fib of 1, because for 2 what we need, I want this value and this value, right? So for fib of 2, I will only call for recursion for fib of 1 only when there is -1 in dp array. If there is -1 represents that the value has not changed. We don't have the answer for that. -1 means that, okay. So fib of 2 means, here we have fib of 1. So fib of 2 has to decide if he wants to call for fib of 1 and fib of 0. Because if we already have the value of fib of 1 and fib of 0 in this array, then we will not call for recursion. But if we are calling for recursion, if we don't have the value, then after we get the value from here, and here, what we will do is, we will store them. So what I will do is, I will do dp of n-1 is equal to answer 1, okay. Else what we have to do is, we have to put this, okay, we have to directly return the value. Otherwise we have to directly return dp of n-1, okay. If the value that we are looking for, so if we are looking for fib of 1, if in dp array it is not -1, if it is not -1, let's say it is 0, okay, and it is 1, okay. So in that case, we will not call for recursion for fib of 1 or fib of 0. In that case, we will not call for recursion for fib of 1 and fib of 0. We will directly use the value from the array. But right now they are -1. Okay. So now, I hope this much is clear. What I have done, if dp of n-1 is equal to -1. If it is -1, then we will call for recursion and we will store the value whatever the recursion will return. Otherwise, I will directly return the value whichever what is there in this dp array. Okay. Same thing we have to do for answer 2 as well. This was for answer 1, and answer 2 as well. We will do the same thing. Okay. here as well we will get fib of, instead of n minus 1 we will have n minus 2. If n minus 2 is not minus 1, so then only we will call for recursion, and then we will store the value as well. Okay, otherwise we will return minus 2. Okay, so this is what we have to do. This is what we have to do, and this should be answer 2. Right, so here as well, right. So this is what we have to do. I hope this much is clear. Anybody has any doubt in this? Which subject related? DP related. Guys, any doubt in this part? Let's dry run it as well so that it will be more clearer to you guys how it is working. We have already done that actually, but let's do it. We have already done that, right? On the second index we stored some value, and we have already done the dry, like we already done the things, but let's do it once again if it is not clear to you guys what is happening. So we started with fib of 4. Okay, we started with, we want to calculate the fourth value. Okay, we want to calculate the fourth value. So how we are going to calculate the fourth value? First of all, I am going to call for, so what will happen is, first of all, the code starts from here, right? It will see that dp of n minus 1. So for fib of 4, I need fib of 3 and fib of 2. I need these two values. So first of all, it will check in the dp array that fib of n minus 1 is minus 1 or not. Okay, for 4 it is checking for second value and this third value and the second value. Okay, so first of all it checked for fib of n minus 1, it checked for third value. If it is minus 1, then we have to call for recursion. That means the answer is not already, like we haven't stored the answer yet. That means we have to call for recursion. So it will call for recursion. Okay, so it will call for recursion for fib of 3. Right, now what will happen? Again for fib of 3 as well, again the same code will run. It will check that dp of n minus 1 is minus 1. So for 3, dp of n minus 1 is dp of 2. Okay, so for dp of 2 it is again minus 1. So again we have to call for recursion. It will call for fib of 2. Okay, it will call for fib of 2. So now what will happen? Again fib of 2, we have fib of 2 here, right? So we will call recursion for fib of 1. We will call recursion for fib of 1. Okay, and from here as well, what I will do is, then again for 1 we know the value of 1, right? So we have to return 1 from there. We will return 1 from there, right? So when we will return 1 from here, what will happen is answer 1 will get value as 1. Okay, for 2, if we take n as 2, so answer 1 will be 1. So now what we will do is we will store dp of n minus 1 is equal to answer 1. So on dp of n minus 1 means for 2 value dp of n minus 1 will be dp of 1. So on dp of 1 we will actually store the value 1. We will actually store the value 1. Okay, I'll store 1 as the value here, right? So now so what happens? So while coming back from the code, from one recursion call, whatever the value I got, I stored it at the first index because it is for the first one. Okay, now what we have to do is it will call for answer 2 now. It will, answer 1 we got, we have stored that as well. Now we will go to answer 2 for value 2. Okay, so for value 2, fib of n minus 2 will be fib of 0. Okay, so fib of 0 we already know the answer is 0, so it will return 0. Okay, and when it will return 0, what will happen is on dp of 0 I will put 0. So now we got the value at the 0th index and the first index, right? Now what I will do is, we got answer 1 and answer 2 both. Okay, we got answer 1 and answer 2 both for n is equal to 2. So now what I am going to do is, I am just going to return answer 1 plus answer 2. That means from here I will return 1. Okay, so for 3, now let's come to n is equal to 3. So for 3 value, the first answer 1 is now 2. Answer 1 is now 1. Sorry, answer 1 is now 1. It called for fib of 2, right? When n is 3, what we have to do is, we will call for answer 2. Okay, just a second. Okay, yeah, we will call for fib of 2, right? We will call for fib of 2. So now dp of n minus 1 will be answer 1. dp of n minus 1 will be answer 1. So at dp of n minus 1 means, for fib of 3, n minus 1 is fib of 2. So at second value I will store 1. Okay, I hope this much you are getting. For n is equal to 3, we call for fib of 2. Okay, and for fib of 2, fib of 2 returned 1, and at the value fib of 2, at the value dp of 2, what I did was I added 1 there. Okay, I added at second index, I added 1 there. Whatever the value fib of 2 returned, I added at the second index. Now we will go to answer 2. Answer 2 will be fib of 1. Okay, now for fib of 1, what will happen is we already know the value in the array dp of n minus 2. That means for 3, n minus 2 is 1. So at second index we have 1, we don't have minus 1, right? So we will directly return n minus 2. We don't have to call for recursion now. It will directly return n minus 1. That means at first index whatever is there, I will return directly that. Okay, now for fib of 3, we got answer 1. We got answer 1. Let me just tell you that. So for fib of 3, we got both the answers, right? We got both the answers. Just a second, guys. Sorry for that. So what happened was we had, okay, so on the third index, now we have both the values, answer 1 and answer 2. So answer 1 was 1 and answer 2 was 1. Okay, so 1 plus 1 is equal to 2. So when fib of 3 for 4 we called for fib of 3, right? So for 4 we called for fib of 3. So when it called for fib of 3, whatever value it is getting, 1 plus 1, which is 2. So it will store at fib of 3, we will store 2. Now the best thing will be on the right side. You will see the thing on the right side that here we will call for fib of 2. For fib of 4 we call for fib of 3 and fib of 2. Now when I called for answer 2, we got the answer 1. Okay, for fib of 4 I got the answer 1 as 2, right? Now when I calling for answer 2, I don't have to call it. Why? Because dp of n minus 2, that means 4 minus 2, which is at the second index 1, it is not equal to minus 1. It is not equal to minus 1, so we don't have to call for recursion. We just have to return dp of n minus 2. We will just return dp of n minus 2. That means whatever is there on the second index, I will return that. That will be 1. Okay, that will be 1. I don't have to call for recursion. I will directly return 1. So 2 plus 1 is equal to 3. 2 plus 1 is equal to 3. I will return 3 as the answer. And you are talking about the time complexity. You can see here on any call. So let's talk about fib of 2, fib of 3. We will only call for once. So whenever we are calling, if the answer is already stored, we will get it. Okay. So we have reduced the time complexity to a greater extent. So it was big of 2 to the power n before. Now it is big of n only. Why? Because we are only calling for recursion when the value is not there. When the value is not stored in this DP array. Okay. Space complexity has also increased. It has increased to big of n, but the time complexity is decreased from big of 2 to the power n to big of n. Okay. Big of n. Right. So this is what we have. This is how DP helps. Right. So now what we have to do is, now I hope this much is clear. Anybody has any doubt in this? How memoization is working? Then I will go to iterative DP. And why? See, if you do this thing also in interview, that will also work. Memoization will also work in interview. Okay. Why? Because this is exactly same like DP. This is DP only. We are storing the values and we are using them. But in some questions you will not be able to use memoization. Why? Because there is a limit. There is a limit in the stack space, right? These calls that we are calling here, these are stored in the stack space. They go in the stack space, right? You all guys all know. So in that stack space gets filled. Okay, at 10 to the power 4 value. If there are more than 10 to the power 4 calls, then it will get filled. Okay, and when it will get filled, there will be a problem. There will be a problem that we will not be able to solve that question. So always remember this memoization approach. This memoization approach you can only use when your n is between 0 to 10 to the power 4. Okay, 0 to 10 to the power 4. If there is value greater than this, then you have to use iterative DP. That means you have to go to no recursion can be used. That means no recursion can be used. You have to do it iteratively. Okay, now we will see how iterative DP works. I hope this much is clear. Anybody has any doubt in this, just let me know. And just give me a minute, guys. You think about the doubt. My battery is low of the laptop. Just give me a minute. Let me open. Yeah, is there any doubt, guys, in this part, memoization? Is it clear? Only one thing we are doing is like normal recursion code. This is a normal recursion code. What we are doing is, this was a recursion code. What we are doing is we are checking first of all that if that value is already there in the DP array, then we are not calling for recursion. We are directly returning that value. Otherwise, if there is value if there is no value, let me tell that again. So in the DP array, if we haven't stored the value already, then we have to call for recursion and then we have to store it as well. Okay, otherwise I will directly use the value whatever is there in this array. Whatever is there in this array, I will directly use that value. Okay, so just let me know guys if this is clear. I hope this is. Now let's come to iterative DP. Okay, so iterative DP. So what is iterative DP? It is simple. It is simple. We just have to know the recurrence relation. Why we are doing the recursive code first? Why we are doing the recursive code first is because we need to know the recurrence relation. Recurrence relation means that we need to know what is the relation between each value, right? If we are calculating for 4, we need 2 and 3, right? If we are calculating for 3, we need 2 and 1, right? So that is what I am talking about. And also, as I told you, what happens in DP is we start from a very small problem. We start from a very small problem. That means this much problem I will solve first of all. Then I will move forward and then I will solve this much problem. Then I will solve this much problem. Then I will solve this much problem. And at last, you can see here, the whole problem is solved. Now, the whole problem is solved. Right? Now, the whole problem is solved. So, this is what we are going to do in DP. Like this is the main DP, iterative DP we can call it. So what we are going to do in Fibonacci series is we are going to start from a very base. Okay. So whatever is the base case you have written here. Okay. 0, 1, 2, 3, 4. Okay. Now whatever the base case you have written here, first of all fill them in this array. Fill them in this array. So on the 0th index, I'll get 0. On the first index, we will get 1. Okay. From the code that we have written for memoization or recursion, we know the base cases, right? So on the 0th index, we have 0. On the first index, we have 1. Now what we have to do is, now this much solution, like for 0, if we want fib of 0, like that means if we want the 0th value of Fibonacci series, we know. Now we know the first value of Fibonacci series as well. Now what we are going to do is we are going to start from 2. Okay, we will see that what was our recurrence relation. Recurrence relation was we want to calculate fib of 2. If we want to calculate, we want the value for fib of 1 plus fib of 0, right? So for fib of 2, we have both the values already there. So what I am going to do is now I am going to solve this much problem, right? So on the second value, what we will get? Sum of previous two, 0 and 1. So 1 will come here. Okay. Now I am deciding that I will solve this much problem because this much problem is already solved. Now I will solve this much problem. So for third value, what we have to do is we need fib of 2, like the second value of the Fibonacci series and first value of the Fibonacci series. Both are available here. Okay. So I will directly take it from the array. So 1 plus 1 is equal to 2. So I have solved this much problem. Now the biggest problem we have to solve now. Like we are starting from a very small problem and we are going to our main problem that we have to solve. Now for the fourth index, what we have to do is same thing. So for fib of 4, we need fib of 2 and fib of 3, right? So second and third value we need. So 2 plus 1 is equal to 3, right? So I will get 3 here, right? And answer will be, at last we will return whatever is at the DP of 4. That will be our answer, right? That will be our answer. I hope this much is clear. So let's try to write the code. Guys, just keep asking the doubts if you have. Public static int iterative dp. Iterative dp. And here what we have to do is int n. Okay, we need int n. We need only n, right? Now I am going to take a dp array, like extra space, okay, is equal to new int n plus 1. N plus 1. Right. Now what we have to do? We have taken a dp array. Now as I told you, first of all we have to fill the base cases. So dp of 0, that we already know, okay, is 0, and dp of 1 will be 1. Right. Now what we have to do? We have to start from the second value. So in the dp array, on the 0th index we have 0, on the first index we have 1, right? 0, 1, 2, 3, 4. Now we have to start from second index and we have to go till 4th. So for int I equal to 2, I less than equal to n, I plus plus equal to n. Now you might get confused why equal to n, because I have taken dp of n plus 1. So I can go till n, right? Because we have on the nth index only we will get the answer, right? So what we have to do is dp of I is equal to dp of I minus 1, right, plus dp of I minus 2. This is what we have to do, right? and then at last we have to return dp of n, dp of n. Okay, at last we will return dp of n. dp of n means fourth value. So now it will start from second index. It will check for dp of 2 will be dp of I minus 1, dp of 1 plus dp of 0. So it will be 1 only, right? Again we will go to third index. Now for third index what we have to do is dp of I, dp of 3 will be dp of I minus 1 plus dp of I minus 2. So 1 plus 1 is equal to 2. Okay, now dp of 4, dp of 4 will be dp of I 3 plus dp of 2. So 2 plus 1 is equal to 3, so 3 will be the answer. Now at last I have to return dp of n. That means whatever value I was calculating for fourth value, so dp of 4 I will return, that will be 3. Okay, that will be 3. See how easy this code is, like iterative dp part. But the thing is to write it, it is easier right now because it's just a Fibonacci series. But as we move forward to the bigger questions, it will become a little bit difficult that directly to write the iterative code. But if you are able to think like, okay, which smaller problem you want to solve, and then you have to increase that one by one. So in that case, you will be able to solve it. You will be able to do it. Okay. So just you have to maintain your mindset that, okay, what is the smallest problem I can solve and how I can increase it, like how I can increase it one by one and then solve the biggest problem, right? So it's just that. Okay. We are actually what we are doing here is we are actually taking each smaller value and we are calculating their answer as well. I am calculating fib of 0 to calculate fib of 4. Then I am calculating fib of 1 as well, fib of 2 as well, fib of 3 as well. To calculate only fib of 4, I am calculating all the previous answers, right? So for fib of 4, if I want from this code only, I can get all the answers from 0 to 4, all the whole series, right? So that is what I am trying to say. If you are able to solve the smallest problem, then you are able to solve the biggest problem as well, one by one. But as if you are starting just learning DP, so in that case what we have to do is you have to first write the recursive code, then try to write the memoization code, and then go to iterative DP. Okay, then go to iterative DP. Guys, any doubt, just let me know in this part. Then I'll take another question now. Guys, any doubt? I hope there is not, right? So let's move forward. And what we are going to do now is next question. Okay, so in the next question that we are going to do is, which is minimum steps to 1. Or let's not do this, let's do staircase problem. Last time we didn't do it, right? So let's do staircase problem. Okay, staircase problem. So let's first of all search it on the net, then we will do it. Okay, so staircase problem. Okay, so staircase problem we have here. So okay, this was some different kind of this. Okay, so let's do this, right? The question is this, right? There are n stairs that you are given with, right? And a person starting at the bottom wants to reach the top. So a person is there who is starting at the bottom of the staircase. He wants to reach the top. Okay, the person can climb either one stair or two stairs at a time. He can only climb either one stair or two stairs at a time. Okay, count the number of ways the person can reach the top. We have to find the number of ways the person can reach the top. Okay, so let's do this. I hope the question is clear. Let me tell you again, explain it. Okay, so let's say this is the staircase that we have. 1 2 3 4. Okay, so 0 1 2 3 4, right? So a person is starting from here and he has to reach the top. He has to reach here. We have to find the number of ways he can do this when you can only take one step or two step at a time. You can either take one step or two steps at a time. Okay, so if you take one step, this is a one way. Okay, and if you take two steps, you can directly take two steps as well. You have to find the number of ways. Okay, just erase this. Let's go to third stair, this third stair only. Okay, let's go to till third stair only. Right. So now what we have to do is, we have to calculate it. Okay. So what are the ways? So if see, one way he starts from 1, 2, 3. This is a one way. Okay, like one step, one step, one step. He will reach the top. Next way can be he can take one step and then 2 steps. This is another way. That is 1 plus 1, 2 ways. Right. Now another way can be he can go for 2 stairs and 1. Right. So it will be one more. So 1 and 2 steps. Right. So total 3 ways. Now any other way is possible? I don't think so. 1, 2, 2, 1. Yes. Only 3 ways are possible. Right. Only 3 ways are possible. So the answer for this will be 3. Right. The answer for this will be 3. So let's see that as well if answer is correct. So consider the example shown here. Okay. They are also showing the same example. Yeah. So yeah, the answer is 3 only. So to reach the top, there are 3 ways. There are 3 ways to reach the top. Okay. You have to give the answer this 3. You have to give this answer as 3. This is a staircase problem. Okay. You have to give the answer as 3. So can we do that? How can we do that? How can we think about it? Right. So we are going to do the same thing. First of all, we will see that directly if we are able to do it. Like no, we will not be able to do it because there are a lot of ways. It is permutation and combination. There can be a lot of permutation and combination possible. Directly we will not be able to deduce any formula and we will be able to do it. So what we are going to do is we are going to use first of all recursion in it. Okay. And how we use recursion? We see that is there any smaller problem that we can solve so that this bigger problem can be solved? Okay. So is there any smaller problem that we can solve if this bigger problem can be solved? Just like Fibonacci series. Yes, there is smaller problem that we can solve. The smaller problem that we can solve in this case is, let's say if we know the number of ways. Okay, if we know the number of ways to reach second stair and if we know the number of ways to reach first stair. Okay, total of that will be our answer. How I can say that is because let's say I go from here to here. Okay, I go from here to here. One step I'll take. Okay, and I know that only one step I have to take, I will reach 3. Okay, so if I know the number of ways to reach the first stair, okay, and if I know the number of ways to reach the second stair, that will be my answer. Okay, I can solve this bigger problem with the help of these smaller 2 problems. How? Because after reaching second stair or first stair, we have to just take one step. We just have to take one step more and we will reach the top. That means the total number of ways that we can calculate. If we can calculate the number of ways for this part, okay, to reach the first stair, and if we can calculate the number of ways to reach the second stair, and we add them, if we add them, so their sum will actually give me the number of ways to reach the top of this staircase. Okay, so what we have to do is we need to calculate if the staircase of n minus 1 we need to calculate plus staircase of n minus 2. Their sum will actually give me the answer. Okay, just let me know if this concept is clear, what I am trying to say. Okay, so let me just tell you what I am trying to say here. That what I am saying is that if I want to reach the top, if I want to reach the third stair, okay, so what will happen is if I know the answer to the first stair, if I know the answer to reach the number of ways to reach the first stair, and if I know the number of ways to reach the second stair, okay, so that will be my answer. Why? Because after reaching first stair, we have to take just one step more and I will reach here, and after reaching second stair, I just have to take one step more and I will reach there. Okay, so this is what we have to do. Just let me know guys if this is clear, this concept is clear. If I am starting from here, let's take another example. Let me start from here. Okay, I want to jump here, then I will jump here. Okay, and the person is saying that tell me the number of ways how you can reach here, how you can reach after jumping here. Okay, and you are only allowed to take only one jump at a time, or you can just skip one, like you can just jump here or you can just jump here. Okay, so if I know the number of ways to jump on this stair, what will happen is I just have to take one more jump and I will reach here. That means if I know, okay, one jump here I have to take, and if I know that I will reach here, that means this is one way. This is one way. Okay, so if I know the number of ways to reach at this position, if I know the number of ways to reach at this position, I already know that this will be same as to reach the this position, because next step is I just have to take one more jump and I will reach here, because we are talking about ways. Don't get confused that we are talking about how many jumps we are taking. No, we are talking about the ways. If I know the number of ways to reach here, then I have to take one more step. So I am talking about this. Let's say I take one step. This is one step I am taking. Then one more step I am taking. One more step I am taking. Okay. So if I know that, okay, two steps I have taken. If I have to just add one step, this will be my one way. This will be my one way of reaching the top. Okay. If I have already reached at the second position, I know that I just have to take one more step, and this will be one way to reach the top. Okay. So this is what we are doing. We are actually thinking that if I know the number of ways to reach n minus 1th stair and number of ways to reach n minus 2nd stair, so their sum will be my answer. Their sum will be my answer. Okay, let me explain it a little more further so that you guys don't have any doubt. So in this example only, if I know, like, on the first stair, how many ways I can reach? One way. Only one way is there to reach at this stair. Okay, because it will be like this. We took one step, and then we take one more step, and we will reach the top. Okay, because we can take this one step, and then I take one more step, and I will reach the top. So this is the first way. Okay, now let's come to the second way. If I know the number of ways to reach second stair, let's say I know the number of ways to reach the second stair. How many ways are there to reach the second stair? 1 and 2. Okay, 1 and 2. What are those two ways? You take one step and one step. Okay, then only you take one step. Okay, at a time you take only one step of two sides. So let's say 2 here I am writing for two steps when we are taking at a time, and this one. Okay, so it will be 2. Okay, and in both of them, if in both of them I just have to add this one step more. So one step, and I will reach. This is another way, and this is another way. So total number of ways are 3. Total number of ways are 3. Okay, so what I am doing, just let me know guys if this is clear. If I know the number of ways to reach n minus 2nd stair, and if I know the number of ways to reach at n minus 2th stair, that will be my answer. If I know this part, and if I know the number of ways to reach second stair, if I know the number of ways to reach the first stair, if I take the sum of them, that will be my answer, because you just have to take one more step, just one step or one step, and you will reach the top. Okay, this is what I am trying to say. Anybody has any doubt in this, just let me know guys. Then I will move to the code. We will do all the 3 codes. Okay, I hope this is clear. So let's write the code. Okay, let's write the code. We already got the recurrence relation, right? Recurrence relation is we need to find the n minus 1, like number of ways to reach n minus 1 stair, and we need to find the number of ways to reach n minus 2 stairs. Okay, and we just have to take the sum of that. Okay, and as we know in the recursion part, what we have to do is we have to assume. I'll assume that recursion will give me this thing, and recursion will give me this thing, like number of ways to reach n minus 1 stair and number of ways to reach n minus 2nd stair. This will be given to me by the recursion, and what I have to do is I just have to add them and return it. Okay, what will be the base case? Base case will be if n is equal to 1, like the basic solution. If n is 1, we have to return 1. Okay, because to reach the first stair there is only one way, and if n is 2, we also know that. Okay, for second stair as well, I know that. Okay, there are 2 ways to reach the second stair. One way is this, 1 by 1, and directly. Okay, so there are 2 ways. So I know both of these things, so I will return 2 here. These will be my base cases. These will be my base cases, because they have told in the question that you can take only one step at a time or 2 steps at a time. So this is a basic solution that we should actually know. Okay, this is the base case. That's why they are called base cases. So let's write the code here. Public static. Just let me know if you are clear with the number of ways part, like how we are calculating the number of ways. I'm just why I'm telling again and again is what I'm trying to say is, let's say you start from here, you want to reach here. Okay, so I start from here, I have covered this much distance. Okay, I have covered this much distance, and there are number of ways. Okay, so if I cover this much distance as well, this will be considered as one way only, right? Okay, now let's say there is one more condition. You can only cover 1 kilometer at a time, or you can cover 2 kilometers at a time. Okay, so now tell me the number of ways. So when you are covering 1 kilometer at a time, and at last only 1 kilometer is left, okay, so you will say that, okay, if I know the number of ways to reach this position and only 1 kilometer is left, then I know that the number of ways I have gotten from here, that will be my total answer, that will be my answer, because this 1 kilometer, I have no choice. After that I don't have any choice, I have to take only one step only, okay. So that I don't have any choice, I cannot have number of ways here because only 1 kilometer is left. Same way for n is equal to 2, for n is equal to 2 as well, if 2 kilometers are left at the end, so I will take just one jump and I will reach here, okay. And there are no number of ways here, no number of ways possible, because there is, for 2 they are giving in the question that, okay, you can take 2 kilometers at a time, you can cover 2 kilometers at a time, and that is considered as something, okay, that is considered only one way, okay. That's why I am saying that don't get confused, it is number of ways that I am talking about, okay, not the how many jumps we are taking. Students tend to get confused in this. So I have no idea about it rhythm, that if they will be deleted. I think they will not be, most probably they will be here, no, nothing will be deleted in 10, right? So staircase we have. Now what we have to do is, if n equal to 0, n equal to 1, then we have to return 1, right? And if n equal to 2, we have to return, right? And at last, and these were the base cases, and now what we have to do is, int answer 1 will be staircase n minus 1, right? We have to calculate the two answers, n minus 1 and n minus 2, okay. And int answer 2 will be staircase n minus 2, okay. And then we have to return, answer 1 plus answer 2, okay. So this is what we have to do in a staircase problem, right? And we can actually test it as well. Staircase, we have to call for value 3, right? So let's run it. So for 3 value, answer is 3 only, and that we were expecting as well, okay. So now you can see here as well, so for n is equal to 4, let's say for n is equal to 4, the answer is 5, right? You can see here they have written that as well, that, okay, one step, then one step, 2 steps, 2 steps, one step, 2 step, okay. So it will be, if we calculate for n is equal to 4, okay, then what we have to do is we have to run it, okay. The answer is 5, okay. That means we are getting the correct answers for every value, okay. Now let's see if there are overlapping subproblems. There will be. This is just like Fibonacci, right? The recurrence relation is same, so there will be overlapping subproblems. So if we are talking about staircase of 3, okay, then what we have to do is we have to call for value 2 and 1, right? Or let's say for 4, if we are calling for staircase of 4, what will happen is it will call for staircase of 3 and staircase of 2, okay. Now what we have to do is, for 3 it will call for staircase of 2 and staircase of 1. Here as well it will call for 1 and 0, right? And here 1 and 0, okay. So here you can see again that 2 is repeating, okay. So what we are going to do is, there are overlapping subproblems. Now only we can use DP. If there are also overlapping subproblems, then only we can use DP, okay. So it will be exactly same as the previous code that we have written. Actually, there will be not much changes. So let me just write it directly. You just have to store these values. Only one thing will change is this base cases, right? So we have to return these values, instead of in Fibonacci series we were directly returning for n is equal to 0 and n is equal to 1. So here we are returning for n is equal to 1 and n is equal to 2. Other things will be same. Other things are going to be same, right? So let me write it. Let me directly write the code. Okay, so staircase, if we are talking about memoization code of staircase, it will be exactly same as the Fibonacci one. Static int staircase memoization, okay, and in which we are passing int n. Right? So what we have to do now? Is we have to calculate if so same thing we have to do exactly what we have done in the Fibonacci part. I hope you will be able to write it. Anyone who wants me to write it, I can write it, that's not a problem. So here as well we will take a DP array, okay. Here as well we will take a DP array of size n plus 1, that will be of size 5 if we are talking about n is equal to 4. So now what we will do is 0, 1, 2, 3 and 4. Okay, and we already, so this will be the case, and while returning back from any call, we will keep storing it. So what we are going to do, base conditions will be same. If n equal to 1, if n equal to 1, we will return 1. Okay, and if n equal to 2, we are going to return 2. This will be same. Now what we have to do is the same thing we will change here as well. So let's take it, and here we will have a dp array, int dp. Okay, so now what we are going to do, we have to actually take control x. Okay, so if n equal to 0, okay, if not n, sorry, if n minus 1, dp of n minus 1, dp of n minus 1, if dp of n minus 1 is not equal to minus 1, so initially we are going to take all the values as minus 1, right? If dp of n minus 1 is not equal to minus 1, what we are going to do, we are going to call for, sorry, if equal to minus 1, let's say, if it is minus 1, so we are going to call for recursion. So in answer 1 will be equal to staircase, same thing that we have done in the Fibonacci part, staircase for n minus 1 and dp, okay, and then we have to store the value as well. We have to, while coming back from the recursion, we have to store the value as well. So dp of n minus 1 will be answer 1, right? Else what we have to do, we have to actually call for this part, we have to actually call for staircase memoization. Okay, otherwise what we have to do is we have to call for dp of n minus 1, we have to just return dp of n minus 1 otherwise, right? We will return dp of n minus 1. Okay, so this is the case. This is for answer 1, right? Otherwise for answer 2 as well, we have to do the same thing, right? We have to do the same thing for answer 2 as well. So right, so here for answer 2 it will be n minus 2 minus 1, answer 2, n minus 2, n minus 2 is equal to answer 2, right? It will be n minus 2. So answer 1 plus answer 2, this will be the case, and this is the answer, right? This is what we have to do in this case, and the answer will be same. So let's call for staircase memoization, let's call for 4, we will get the same answer. There is an error, so let's see what is the error. Okay, I haven't passed the dp array, so I'll have to pass the dp array as well, and that dp array initially will have all the minus 1 values. So for, first of all, let's make a dp array here, int dp is equal to new int n plus 1, okay, n plus 1. So let's take this n from the user only, okay, so scanner s is equal to new scanner, okay, new scanner system.in, okay, and what we have to do is let's import this as well. Okay, let's import this as well. So scanner will be this, and int n is equal to s.nextInt. So this this will be given by the user, and whatever the value he will give, I will take a dp array of that of n plus 1 size, and I'll pass this dp array, and here we will pass the n as well. Okay, this is much better thing to do. So let's run it. So first of all, it is asking me for the value. So let's say 4 I am giving it. So the answer is 0. So that means there is some problem. Okay, I haven't given it the value minus 1. Okay, we have made the dp array, and we have to make all the values minus 1 as well. So int I equal to 0, I less than dp dot length, I less than equal to n, I plus plus. Okay, and what we have to do is we have to give I should be less than equal to n, and what we have to do is dp of I is equal to minus 1. Initially we have to put it minus 1, right? So now let's run it, and for value 4 we are getting answer as 2, so that means it is wrong. So we have to see where is the issue. Staircase mem, we have to take sum of answer 1 and answer 2, and base cases are for n1 we have to return 1, for n2 we have to return 2. answer 1, dp of n minus 1 is equal to answer 1. This seems okay to me, but what is the issue here? So here n is equal to 1. LIS, yes, I can do that. LIS, longest increasing subsequence, right? You're talking about that. So actually there is a video of mine of the same, like on this channel only, if you want to see that. In that I have covered LIS, and one more thing I have covered in that. We can do this, just give me a second. Okay, so just give me a second, let me do this thing, like what is the issue here, then I'll show you that. So n minus 2 is minus 1, n minus 2 is answer 2, otherwise we are just equal to minus 1, then only we have to call and we have to store it as well, right? And else we have to return the answer 1. So we are calling for n is equal to 4, so the answer should be 5, right? So if I talk about this, we are returning answer of 5 plus 6. Okay. So I hope this is correct. But there might be some problem. So let me just tell you, see how we can try it as well, and let's see if it is working fine, right? So what we are going to do is dp of n minus 1 we have, okay, dp of n minus 1 will be for value 4, okay. Let's talk about value 4. So for value 4, what we are doing is if it is minus 1 or if it is minus 1, right? So we have to say, okay, number of ways we are talking about. So we have to add them, right? Yes, we have to add whatever the two answers we are getting, we have to add them. We don't have to do anything else. And so let's see. Okay, so let's see with an example. So for n is equal to 2 and dp is equal to an array. Okay, dp is equal to an array. So n is equal to, let's say, 4. For n is equal to 4 we are talking about. So first of all I'll call for n is equal to 4. I'll call for n is equal to 3. Okay, because 3 is not there, I'll call for n is equal to 3. Then I'll call for n is equal to 2, right? So when I'll call for n is equal to 2, because they are all minus 1 initially, so what will happen is it will return directly 2 from here. Then I'll call for n is equal to 1, it will directly return 1 from here, and their sum will be 3. So at index what? N minus 2, I will have 2 here, I will have 1 here. Not talking about the 0th index. Are we going to 0th index in any case? I don't think so. We're going on 0th index in any case here. So just let me just try it properly. Okay, let's see if we are going on 0th index. So 0 index, 1 index, 2 index, 3 index, 4 index, right? Here it will be minus 1 initially, minus 1, minus 1, minus 1, minus 1. So when it will return from here, n is equal to 2 will be 2 and n is equal to 1 will be 1, right? And then what we have to do is, then we will get n is equal to 3 as 2. N is equal to 3 as 2. Okay, now we got that answer 2 from here, 1 plus 2, 3. For n is equal to 3, it will be 3. Now it will call for n is equal to 2. Okay, it will call for n is equal to 2. So n is equal to 2 we already have. So if n is equal to 2 is minus 1, then we have to call for recursion, otherwise we have the value, right? So it will return 2 from here. So sum of 3 and 2 is 5. So it should return 5 according to the code as well, but there must be some issue. If it is minus 1, we have to call for n minus 1 dp, then n minus 1 will be answer 1. Okay, otherwise we have to return answer 1 only. So n minus 2 is minus 1, we have to call for n minus 2 and we have to store that, and else we have to return dp of n minus 1. So this seems okay to me, but why? Let me just, 2 value is for dp of 2. So let's do one more thing. Let's try it for n is equal to something else. N is equal to 3. So answer is 3. For 3 the answer is 3. That is not a problem. Okay, that means for till 3 it is working fine. But when we are going to 4, now it is giving value as 2. Now it is giving value as 2, and for 5 we are getting 3. So that is not correct. For 5 it should be greater, right? So we have to try run it properly, okay, so that we will get the issue, right? So let's do it. 0, 1, 2, 3, 4. So overall -1. Okay, so now what we have to do is let's see where is the issue. This will be an interesting thing that we can find the issue. So initially what we are going to do is we are going to call for staircase of n is for n is equal to 4, right? So now what will happen? It will call for answer 1. It will see n minus 1 is -1. Yes, it is -1. So it will call for recursion for n is equal to 3, right? So now when we call recursion for n is equal to 3, there is -1 there. Okay. So for n is equal to 3, again the same code will run. So what will happen? Staircase, it will again call for n is equal to 2, right? So when it will call for n is equal to 2, what will happen in that case is we will get 2 from here. We will get 2 from here. And when it will get 2 from here, when it was n is equal to 3, we get 2 from here. So now we have to show dp of n minus 1 as answer 1. dp of n minus 1, which is dp of 2 as minus answer 1. So answer 1 will be 2. Okay. So at second index we have to write 2 there. Now what we have to do is we have to go for answer 2 for n is equal to 3. That will be we have to call for n is equal to 1, right? So when I will call for n is equal to 1, it is -1. Yes. So what will happen? Answer 2 will be we have to call the recursion for n is equal to 1. So now it will return 1 from here. It will return 1 from here, and I have to fill dp of 3 minus 1 2 is equal to answer 2. It will be filled with 1. Okay. So the first index will be filled with 1. So 1 and 2. Now what we have to do? For 3 we got the answer. Okay. So from here what we will return is sum of both of these. That will be 2 plus 1 is equal to 3. So 2 plus 1 is equal to 3. Okay. So where it will return? To 4. So for the first answer of 4. So it will be 3. Right. So dp of n minus 1. dp of n minus 1. That means on the third index we will have 3. Okay. Till now it is working correct, absolutely fine. Right. Now what we have to do is we have to call for answer 2. So for answer 2 we have dp of n minus 2 is -1. No. dp of 4 minus 2, at second index we have 2, right? So at 2 it is not -1. So it will directly return dp of n minus 2. So it will return 2. Okay. So when it will call for n is equal to 2, it will directly return 2 from here. Okay. So now we got the answer 1, which is 3, answer 2 as 2. When we take the sum of this, the answer will be 5. So absolutely fine, it is working. As the dry run as well, it is working as absolutely fine. So what is the issue? Answer 2, answer 1 plus answer 2, dp of n minus 2. It is working perfectly fine. If I am calling the same code, yeah, can't find it. Okay. So let's go to the iterative code first. Let's see what is the issue, if we will be able to find it. Right now I am not able to, because it seems perfectly fine to me that we are returning dp of n minus 1 and n minus okay. I think I got it, because I am returning from here only. Okay, I am returning from here only. I don't have to return from here. I actually have to give this value to answer 1. Okay, sorry. Answer 1 will be this, then answer 2 will be this. Answer 2 will be this. Yeah, I got it. So answer 1 and answer 2, the values we are giving are to answer 1 and answer 2, not actually to, we don't have to return from there. Okay, then there's some we have to return, right? That was the case. So now if I run it, the answer will be correct. So we have to give, let's say 4. So answer is 5. Yeah, now it is working fine. Now it is working fine. The only problem was we have to give answer 1 the value that we are calculating, right? At last we have to return their sum, answer 1 and answer 2. Okay. So now let's go to the iterative code. Public static void int and staircase. Staircase iterative it. Okay. Here as well what I will do is I will pass int n. Right. So now what we have to do? Now what we have to do is we have staircase iterative code. We have to write. This is same as Fibonacci. Okay. So what we have to do is we have to take a 1D array 0, 1, 2, 3, 4. Okay. On the 0th index we will have 0. On the first index we will have 1. No. In this case it will be different. So we have to fill the base cases first. As we know in the DP code, first thing we do is we fill the base cases. Okay, so for n is equal to 1 we have to fill 1, for n is equal to 2 we have to fill 2. Okay, and all the other values are minus 1 initially. Okay, and minus 1 initially. Now what we are going to do, we are going to start from n is equal to 3. We are going to start from n is equal to 3, and we know the recurrence relation. Recurrence relation is, as I already told you, recurrence relation, first thing you should know, and you should know where to start, like the smallest problem where you will start. So here, after filling the base cases, we have to start from third value. Okay, now I will solve this much problem, and then I will solve this much problem. So this much problem that I am solving is for n is equal to 3. For n is equal to 3, the sum will be 2 plus 1, 3. Okay, so here we will fill 3. Here we will fill 3. Right. Now what we have to do for n is equal to 4, then I will go for n is equal to 4. So for n is equal to 4, what we have to do? We have to fill 3 plus 2 will be 5. That means previous two values, sum of previous two values. So it will be exactly same. So what we have to do is, first of all we will take a DP array. DP is equal to new int n plus 1. Okay, n plus 1. Now what we have to do is, for int I equal to 3, first of all we will fill the base cases. Let's fill the base cases first of all. So base cases will be DP of 1 will be 1, right, and DP of 2 will be 2, right. And now what we have to do is, we have to start from third value. For int I equal to 3, I less than equal to n, I plus plus. Okay, now what we have to do is, DP of I is equal to DP of I minus 1 plus DP of I minus 2. Return DP of n. Right. This is exactly same as the Fibonacci one. We'll start from. So what I am doing is, let me just tell you as well. So we have 0 index, first index, second index, third index, fourth index, right? We have to start from, all the values will be initially, we will take 0 as well, doesn't matter in DP part. So on, let's say initial values are 0. So what I will do is, on the first index I will have 1, on the second index I will have 2. Okay, now what we have to do is, we have to start from third index. What I will do is, DP of 3 will be previous to sum, 2 plus 1, 3. Okay, so here we will have 3. Now for DP of 4, I is equal to 4, what I have to do is, I will have to take the sum of previous two values, 2 plus 3 plus 2, that will be 5. So DP of 4 will be filled with 5. At last we have to return DP of 4, that will be our answer. Okay, exactly same as Fibonacci series, but this is also a problem that is asked in a lot of interviews. Okay, a lot of interviews. So that is the case. I hope this is clear. So let's run it as well. Staircase IT. We don't have to pass DP here. When we run it, we have, let's say for value 4 we want to check, the answer is 5, right? So it is working fine. So we have done two problems, right? We have done Fibonacci series, we have done staircase problem as well. Let's do one more, right? The last one for today, so that you will get the idea. Okay, in this we will do some small less work than what we have done till now. So what the question is minimum steps to 1. Okay, minimum steps to 1 means that we have to start, we are given with some conditions, we are given with a number. First of all, we are given with some number, let's say 10. Okay, we have n is equal to 10. So what we have to do is, we have to actually take this number, and we have some conditions. 3 conditions we have. The first condition is, if the number is divisible by 2, we have to actually make this number 1. Okay, that 1 means that from 10 to 1, we have to take it from 1 to 1, but we have some conditions for that. So if n is divisible by 3, then what we have to do is, we can make the number n by 3. Okay. Second condition is, if n is divisible by, that means if n is divisible by 2, we can do the number n by 2. Okay. And if n is divisible by 3, otherwise one condition is always true, that we can subtract a number by 1. Okay. Okay. What we have to do is, using these 3 conditions, we have to make this 10 equal to 1. Okay, so this is the condition. Anybody has any doubt in this, like what is the condition I'm talking about? So the question is, we are given with a number, Okay, and this number we have to convert it into 1. We have to convert it into 1 from 10 to 1, right? So now what we have to do is we have some conditions to make it 1. Okay, so if n is divisible by 3, we can do n by 3. If n is divisible by 2, we can do n by 2. And if n, and always we can subtract n from, like 1 from n. Okay, we can always subtract 1 from n. Always subtract 1 from it. So this is always available. We can subtract it. So how many number of ways? We have to calculate the minimum number of ways. We have to calculate the minimum number of way we can do this. Okay, so if 10, we are given with 10, so there are different ways, right? So in the minimum number of steps it will take. So for 10, you can say that it is not divisible by 3, it is not divisible by 2. Okay, we can subtract 1 from it, it will become 9. Now it is divisible by 3, so we can make it 3, and then again it is divisible by 3, we can make it 1. Okay, so this was 1, 2, 3, 3 steps, right? Another possible way can be 10. We can have 10, and then we can, it is divisible by 2, so we can have 5 here. We can convert it into 5. So now it is not divisible by 3 or 2, so we can subtract 1 from this, and then we can again, it is divisible by 2, so we can make it 2, then again it will become 1. Okay, again when we divide it by 2. So now 1, 2, 3, 4. 4 steps, here we have 3 steps. So minimum number of steps will be 3. Okay, so now the main problem in this question is students think that, okay, so we have this problem, but we can do this in greedy way as well. Okay, students think that we can do this in greedy way as well. This is dynamic programming approach that we have to follow. We have to see all the paths and then we will decide what is the correct answer. Okay, dynamic programming simply means that we are going on each path and then we are deciding which is the best answer. But in greedy approach, as I told you initially as well, it means that at that time what is the best solution we have to choose. Okay, at that time what is the best solution that we will choose. Okay, so in this case what we are going to do is, we have, let's say 10. Okay, so first thing, if you are using a greedy approach, what you will think about is, let's say if you are given with a number that is divisible by 3, 2, or we can subtract 1. So you will choose the biggest one. Okay, you will choose the biggest one. You will see that if it is divisible by 3, then you will divide it by 3. Then you will come to n by 2. Okay, because you want to decrease the number as soon as possible. So the greedy approach the first approach that will come into your mind will be this only. That okay, it can be divisible by 3, it can be divisible by 2. Then we will subtract 1 only. Okay, so in the case of 10, it will fail. How? So if we have 10 here, what we can do is 10. First of all, is not divisible by 3, so we cannot do anything. It is not divisible. It is divisible by 2, so we will directly do 5. Okay, we will directly convert it into 5. Now you will see that it is not divisible by 3, it is not divisible by 2. We can subtract 1 from it, so we can make it 4. Okay. Now for 4, again you will say that okay, it is not divisible by 3, so let's divide it by 2. So it will become 2, right? And for 2 as well, you will say it is not divisible by 3, it is divisible by 2, so we will make it 1. Okay, so this is the wrong answer. They are giving you 4 steps. The answer is 3 steps. In that, first of all you will subtract 1, and then you divide it by 3, then you divide it by 3, the answer will be 1. So number of steps here will be 3. So you have to think it in a dynamic programming way, not in this way, not in greedy approach. Okay, not in greedy approach. So what we have to do, how we can solve it? So first of all, the recursive solution. Recursive solution is very simple. First of all, we will call for n minus 1. Okay, we will call for, if it is divisible by 3, we will call for n by 3, and if it is divisible by 2, we will call for n by 2. Okay, and whatever the solutions we will get, we will take the minimum of that. Okay, and if we reach 1, we will directly return 0. Okay, if we reach 1, that means see, if the number you are given with is 1 only. Okay, so it is already equal to 1, so the answer will be 0. Like 0 number of steps will be taken, right? That will be our base case. Okay, so what we are talking about is for 10 we will explore all the paths. First path will be for subtract 1, we will take this path, then n by 3. Okay, n by 3 will be, it is not divisible by 3, so we cannot take that path. It is divisible by 2, so we can take that path, it will be 5. Now again, we have to take 3 paths here, 3 paths here. Okay, so if you go to the worst time complexity of this, that will be 3 to the power n. Okay, and there will be repetitive cases. There will be repetitive cases in this as well. Okay, so we are going to use DP in this. So at any point it can become 5, right? It can become 5 as well. So 5 and already calculated, so we don't have to again calculate 5. That's why I'm saying there will be an overlapping subproblems. So it is not, we have to use DP in this, right? So first of all, let's write the code. Okay, so what I'm talking, one more thing, that we have 5 here. Okay, so we have 10. Okay, so whatever the number of ways I will get from this path, whatever the number of, sorry, no, not number of ways, number of steps I'll get from this path, minimum number of steps, whatever the minimum number of steps I'll get from this path, I'll take the minimum of that, and that will be our answer. I'm telling recursion that give me the number of paths from this path, number of steps from this path, and from this path as well, and I will do the minimum of that and return it. I will do the minimum of that and I will return it. Okay, so that will be the case. So this will be done by recursion only. Only our work is to take the minimum of that and return it. Okay, take the minimum of that, all the paths, and return it. Right? So this is very, very simple. So let me just write the code directly. And someone was asking for LIS. So if you go on the dynamic programming playlist of mine, you will see the second video we have this. Okay, in the second or third video we have done LIS. So you can go and check that. Okay, so public static int, and what we have to do is we have to, which question we are doing, steps, minimum steps, right? Minimum steps. Okay, so here we will have int n, right? So now what we have to do, simple recursive solution will be if n equal to 1, this is the base case, we have to return 0. If n is already 1, so the number of steps will be minimum will be 0, right? Now we have to call for 3 calls. We will do 3 calls. 3 calls will be minimum steps, int 1, int answer 1 will be minimum steps for n minus 1. Okay, second answer will be that if n is divisible by 2, we have to take answer 2. Okay, so here it will be int answer 2. Okay, so if n is divisible by 2, we'll call for answer 2 is equal to min steps and n by 2. We'll call for n by 2. Okay, and here answer 2 will be initially 0. Let's say not 0. It will be we have to take the minimum, right? So let's give it a maximum value. Integer dot maximum. Okay. Now for a int answer 3 is equal to integer dot max value, right? Why max value? Because initially we are taking the max value because we have to take the minimum of all 3. Okay, so if this is infinity, and this is 1, if I take the minimum of that will be 1 only. Okay, so I'm taking the max value only if there is no, so if it is not divisible by 2, I'm saying that there are infinite ways to, like, there are infinite steps to reach there. Okay, I'm saying there are infinite steps to reach there, and usually when we are taking the minimum, we always take the max value only in the answers. Okay, at last we are going to take the minimum of all the three ways that we are taking. Okay, that's why. So if n modulus 3 equal to 0, then we have to, what we have to do is answer 3 will be equal to min steps for n by 3. Okay, now what we have to do is we have to take the minimum of all 3. So we have to return math dot minimum of all 3, answer 2, answer 1, and then math dot minimum of answer 1 and answer 3. Okay, this is what we have to do. Take the minimum of all 3, and the question is done. Whatever the question says, we are doing that here. Okay, this is how it is working. So now what we have to do is, let's call it minimum steps. Let's call that. So minimum steps for n. Okay, for n. So whatever the n value I'll pass, it will give me the minimum steps to reach there. So for 10, we already know the answer is 3. So let's test it for that. Here it is. Okay, minimum steps. Okay, so let's run it. N is equal to 4 or 3. 3. We already know, right? For 10, we already know the answer should be 0. Why? So there is some problem here. Maximum value, and whatever it will return will be 0, 0, maximum 0. That is okay. N by 2, n by 3, maximum value. it should not be 0 because the answer is 10, and we are calling for n is equal to 10, right? So we are calling for n is equal to 10, so it will be minimum steps. If n is 1, we have to return 0. Answer 1 will be, we will call for 9, okay? So then it will call for 8, it will call for dash dash dash. So from here it will return 0 from right side. If n is not divisible by so, it will return. So it looks okay. The code is okay, but what is the problem here? A math on minimum of all three, and we have to do this. And by 2, answer 2, answer 3. Okay. So for every value it is giving answer as 0. Let's see that. For 4 as well, yeah, for every value it is giving answer as 0. So when n is 1, we have to return 0. Okay. So let's see. Let's try run it as well. So for, let's see for 4 value. Okay. So for 4, what, first of all it will call for 3, then it will call for 2, it will call for 1, and then when it will call for 1, it will return 0 from here. 2 is divisible by 2, so it will again call for 1. So it will again return 1. Okay, it will again return 0. 0 plus 0 is, so minimum of 0, 0 and infinity will be 0. From here it will return 0. So it is divisible by 3, so it will call for 1. Again it will return 0. 0 plus 0 and 0 will give me the minimum is 0, 0. So minimum will be 0 only. Yeah, it is returning 0 in all cases, right? So where is the problem? What we have to do is, when we reach 1, the answer will be 1 or 0. It will be 0 for sure, but if we never reach 0 as well, that's not a problem. So we have to take the minimum of all three. Okay, I have to add 1 here. I haven't added 1 here. 1 plus. Okay, so what I was saying was, is because, so let's say I am calling for 3, let's say for 10 only. Okay, so I am calling for 9 as well, I am calling for 5 as well. Okay, so I know the minimum number of steps from this position to this position, that is will be given by recursion here as well, from this position to reaching 1 to this position to reaching 1. These are the steps that recursion will give me, but this one step it will not give me. This one step it will not give me, so I have to add 1 to it. Okay, I have to add 1 to it. So the answer now will be correct. For 10, let's say the answer will be 3. So number of steps are 3 for 10, right? We already know that. So for 10 it goes like 9 and then 3 and then again 1. So number of steps are 1, 2, 3. 3 number of steps it is taken, right? This is absolutely correct. Now if you want to convert it into memoization, just do it by yourself. Okay, why? Because very easy. You just have to write here conditions, same condition that we have written in Fibonacci as well as that normal part, that is exactly same. So do it by yourself. Okay, do it by yourself. Memoization is very easy. Just you have to write the condition here. If take a DP array, just write the condition that DP of n minus 1 is minus 1 or not, all those conditions, just write that. So then you will be able to do it. Okay, now let's move to the iterative DP code for this. Okay, public static int min steps iterative, min steps iterative. Okay, so in min steps it, what we have to do is we have to actually take simple thing int n. Okay, and how we are going to solve it now? See, so the simple thing is minimum number of steps. Okay, so for we know the base condition. First of all, our base condition we already know. Okay, base condition is for n is equal to 1, we have to return 0. Okay, so for n is equal to, let's say we are calculating for n is equal to 4, so it will start from 0, 1, 2, 3, 4. We are calculating for 4, so the array size will be n plus 1, 5 size. Okay, so for n is equal to 1, we already know the answer is 0. Okay, and for 0 as well, the answer will be nothing, it doesn't matter. So initially it will be 0, all values will be 0. So we have to start from second value. Okay, so one by one we will solve the small problems and then we will reach the top. So we will find the answer for n is equal to 2 first of all. For what are the number of minimum steps we have to take to reach 2 steps. Okay, to reach 2. Okay, sorry, to make 2 reach to 1. So the question is that we are given with a number, we have to convert it into 1 by certain conditions. 3 conditions are given to us. If it is divisible by 2, you can do n by 2. If it is divisible by 3, you can do n by 3. And if it is not divisible by any of them, you can just subtract 1 from it. These are the 3 conditions, right? So now for n is equal to 2, we have to calculate that, okay, how many steps it will take to go from 2 to 1. Okay, so it will take only one step, right? How we will calculate that? So we will see if the answer is stored here. So what we are actually storing here? We are actually storing here for each value what are the minimum steps to reach to reach 2 to 1. Okay, so then I will calculate for 3 to 1, then I will calculate for 4 to 1, right? So at every point we know the minimum minimum value. We know the minimum number of steps to reach from 2 to 1. Then for 3 as well, I will store that only to reach 3 to 1. So at every point we know that in this array we are storing the minimum values to reach that step. Okay, to make that step reach to 1. That is the minimum number of steps we are getting here. Okay, at each index we are storing the minimum only for each. Okay, so for 2 we have to take 3 conditions. It is divisible by 2. Yes, so n by 2 will be 1 only. So on the first index we have 0, so 1 plus 0 will be 1. Okay, this is the recurrence relation I am using. So I'll calculate all the 3 things like n by 2, what is there at n by 2, what is there at n by 3, and what is there at n minus 1. So whichever one will give me the minimum number of steps to reach that point. So for 3 as well, I will take the all 3 values, and whatever will give me the minimum plus 1 will be my answer. Plus 1 will be my answer, right? So let me first of all write the code, then it will become a more simpler, right? First of all, we don't have to fill the base case as well in this. We just have, because all the values initially in array are 0 only. So int dp is equal to new int n plus 1. Int n plus 1, right? So now what we have to do is we have to start from value int I equal to 2, I equal to 2, I less than equal to n, I plus plus. Okay, so now what we have to do is we have to start from dp of I is equal to dp of now we have to take the 3 conditions in place, all these 3 conditions, right? That if it is, we have to take the minimum of all 3. So first of all, int answer 1 will be dp of n minus 1, right? Otherwise all the things will be same, like int answer 2. Initially I will take it as integer dot max value, right? And if same thing that we have done in the recursion, we have to do the same thing here. If I is divisible by 2, if I modulus 2 equal to 0, if I is equal to 2 equal to 0, what we have to do is then I will make answer 2 as dp of I minus n by 2. Then only I will take this in consideration, right? Then only I will take this in consideration. Okay, so if I modulus 3 equal to 0, in that case what will happen is answer 3 will be equal to dp of n by 3. Okay, dp of n by 3. Here as well we will take answer 3 as max value, right? Answer 3 as max value, right? So this is the case. Now what we have to do is we have to take the minimum of all 3. We have to take the minimum of all 3. So dp of I will be exactly similar as the recursive code. You just have to do this. Okay, dp of I will be math dot minimum of all 3. Answer 2, answer 3, and answer 1. Math. We are just storing the values one by one, starting from very basic to end. We are keep storing the minimum values, and then we are using them as well. Okay, we are using them as well. Okay, and then at last we will return dp of I. Okay, at last we will return dp of I. So I will call min steps it. Okay, for 4 the value is again 0, so I think there is some issue I have done. So let me just see that where it is. Okay, I am not going till n, I am going till n, starting from 2, n minus 1. If it is answer 2 will be this, answer 3 will be this, and sorry, 1 plus, again 1 plus, I will return 1 plus. So again we have to do 4. The answer is 2. The answer is correct. For 10 as well we know that, we know the answer for 10. For 10, the answer is again 2. It should be 3. Am I doing the same thing? IT, we have to just pass n. Okay, for 10, the answer should be 3. So what we can do is we can print this DP array and we can see where we are getting wrong, right? We can just simply print this DP array and then we can see where we are wrong. Minimum, okay, this okay, everything seems fine. Yes, so let me just see that. So for int I equal to 0, I less than equal to n, I plus plus. Okay, so now what we have to do is dp of I, so we have to just print dp of I, whatever is there, right, to see the answer. System dot out dot print dp of I. Okay, now print ln, let's say print ln. Now we have to run it. Okay, for value 10, let's see. So it is looking like 0 0 1 1 1 1 1 1 1 steps and then 2 2. Okay, so initially it should be 0 0 1 step. Okay, 1 step. Okay, then for 4 it should be 2. So I is equal to, sorry, n minus 1, not n minus 1, it should be I minus 1. Okay, now it will work fine. So okay, so let me just remove this as well. So now it will work fine. Here also I think I am doing the same thing. So I should be I and it should be I as well, right? Now when I run it, now it will give me the correct answer. It will be for 10, the answer is 3. Now it is giving the correct answer. Okay, so exactly same, nothing much difference, right? We are just writing the same things here that I am writing for this, for recursion part. Okay, so you can try it by yourself as well, right? So you just have to take an array. Let's say for n is equal to, okay, sorry, for n is equal to 5, for n is equal to 4, let's say. So 0 1 2 3 4. Okay, so for n is equal to 4, what we will do is we'll start from second index and we will go to, first of all, see if it is divisible by 2. Yes, it is divisible by 2. So these two values are 0. The value will be 0 here. If it is divisible by 3, no, the value will be infinity here. And if it is n minus 1, I minus 1, 0 only, so it will be give 0 as well. So 0 0 infinity. Minimum is 1. Minimum is 0 plus 1. So answer will be 1. Okay. Now what we have to do for 3? For 3, it will be like n minus 1 is 1 only, right? That means dp of 2 is 1 and answer 2 will be, that is dp of I by 2. So I by 2, it will be infinity only, right? Because it is not possible. And for 3, I by 3, it will be 1. So dp of 1 is 0. So what is the minimum? 0 1 infinity, which is 1 is the minimum. So minimum is 1, minimum is 0. So 0 plus 1 is equal to 1. So it will be 1 here. Okay, same way for last value 4. So for 4 as well, what we have to do is, so n minus 1 is just a second. Okay, so n minus 1, dp of n minus 1, I by 2, so dp of I by 3. dp of I by 3 is nothing, it will be infinity only because 4 is not divisible by 3. For I by 2, it will be 4 by 2, 2. So on the second index we have 1, okay, and dp of I minus 1, 4 minus 1, 3. On the third index we have 1. So minimum of all three will be 1 only. So 1 plus 1 will be 2. So the answer will be 2. So we will return this and answer will be 2, right? So this is how we have to do it. Just think about it, how we can solve the DP problems. We have done 3 problems already. Just do it by yourself as well. It will be very good practice for you guys, right? And do more questions. We already have a full playlist of DP, like my playlist of DP. You can see that, you will find it on the channel. Okay, let's do that as well if you want to learn it, right? So yeah, so I hope everything is clear in today's class. Okay, so just go and join us on Telegram as well, guys. This is very, very important so that you guys get all the updates. And also thank you very much for joining in. Just go like, share and subscribe. Yeah, so bye bye. Anybody has any doubt? I have 2 minutes. I hope there is no doubt, right? So bye bye, let's meet tomorrow, right? I'll have 2 classes tomorrow, so let's meet tomorrow. Okay, let's meet tomorrow, so bye bye.